Hi, and welcome to the 2.15 lesson, The Body and Its Energy. As we get started, don't forget to fill in your science notebook slide for this lesson. There's also a notebook activity in this lesson. And if you struggle with note-taking, just listen for the parts of the lesson that I tell you to add to your notes page, and I'll also be covering the guiding questions so you can jot those down as well. As we get started with the lesson introduction, we're talking about using energy. When you eat a meal, you're fueling your body, and this is similar to putting gas in the tank of a car. How does your body use that fuel, and what is it used for? How many calories do you need to keep your body warm and to perform the activities you do every day? How many calories do you need to take part in activities such as playing soccer? You'll explore these questions in this lesson. There's a graphic organizer in this lesson. I always encourage you to open those up, complete them, you can add them to your notes. They are very helpful. This one is comparing the idea about how your body uses energy. And so you just fill in the age group, weight, and equation used to calculate the rest energy calorie number. And then that's similar to what you'll be doing in the notebook activity. And as we get to the guiding questions, I'll just take a quick screenshot of these so we can answer them as we go along. All right, and as we get into the explore portion of the lesson, let's go ahead and look through storing energy in the human body. The main source of all energy on Earth is the sun. So that's a great thing to put in your notes. The sun's energy gets to Earth in the form of sunlight, and this energy is used by plants, which take in carbon, hydrogen, oxygen, and nitrogen from the air, water, and soil, and they manufacture either carbohydrates, fats, proteins, or a combination of the three. All foods possess stored energy. So this is a great thing to have in your notes as well. When you eat food, your digestive system breaks down the fats, proteins, and carbohydrates into simpler molecules that are absorbed into the body and transported to various cells. So the first question that we're looking at for guiding questions is what happens when you eat food? So here you go. When you eat food, your digestive system breaks down the fats, proteins, and carbohydrates into simpler molecules that are absorbed into the body and transported to various cells. So that's guiding question 1. So where is the energy stored in fats, proteins, and carbohydrates? Chemical energy is stored in the bonds of molecules within fats, proteins, and carbohydrates. So this would be another great thing to have in your notes. Guiding question 2 is looking at metabolism. So metabolism describes all the physical and chemical changes taking place within the body, the transformation of food to energy, the creation of hormones and enzymes, the growth of bone and muscle tissue, and the successful completion of other bodily processes are all part of the metabolic process. You might have heard someone say I have a fast metabolism. So what does that mean? That's the rate of a person's metabolism expresses how rapidly the body uses its energy, the energy it stores. So this metabolic rate is different for everyone because of 3 main factors: the amount and frequency of food eaten, the types of exercise or activities completed, and the total amount of energy needed to run the body's systems, such as pumping blood. So what is metabolism? Here is a good description right here. Basically, this whole paragraph, kind of fueling your body in a pretty detailed way. Food, energy, hormones, enzymes, how your bones and muscles grow. And then what does your body use energy for when you are resting? So that's the next guiding question. But this is an interesting question. Can your metabolism be altered? And yes, the rate of metabolism can be improved by increasing the frequency or duration of activities such as cardiovascular activities. So if you are one that sits a lot during the day, you don't get up and move around or try to get some exercise in during the day, then your body doesn't require much energy, and so your metabolism would be very slow. So as we're moving into the next part, so as we get into resting energy requirements, and this is also guiding question 3, it says if you haven't noticed, teenagers need to eat more food more often than older adults. This is not because of how active teenagers are, it's because your bodies are busy growing. Building bones and muscles requires energy. The energy used while the body is resting goes into building or tearing down substances at the cellular level. And it also involves body functions like breathing and digestion. So your age and weight can be used to get a rough estimate of how much energy is needed to supply your resting needs. And then exercise adds a whole new energy requirement. So is the resting energy requirement the same for all teens? And so you can look from ages 10 to 17, you take 17.5 times your body weight and then add 651. So for example, if you had a 154-pound male, age 20, you would use this formula. And the calories, the resting calories burned would be 1,750. So you can see that changing your body weight is going to be change that number. So no, the resting energy needed by each teenager is different and depends on many factors. One, including the amount of growth occurring in the human body, as well as some inherited genes. So question 3, what does your body use energy for when you're resting? It talks about that here. Building or tearing down substances at a cellular level, and involves body functions like breathing and digestion. So it does take energy for those things to happen. And what equation would you use to determine how much energy your body uses on a daily basis? So this gets us the resting amount, and then the next one, energy for exercise. So it should be no surprise that you use more energy playing a sport than watching TV all day. But how much more energy? So if you look at the calories needed for running at 5 miles per hour, you can see that 9.4 calories a minute are consumed. So if you went jogging at this speed for 30 minutes, you would use 282 calories. So if you play a sport that involves running and your practice lasts an hour and a half, consider how many calories you might be using. Usually you're not running the whole time, but you're definitely using a lot of energy. So if we look at the chart over here, how much energy is needed to walk at a 3 mile per hour pace for 30 minutes? So walking at 3 miles per hour, you would take 4.2 times 30 minutes, and it gives you the answer 126 calories. So if you think about the small cans of soda, the 7.5 ounces, the mini cans, those are about 100 calories. So if you're walking for half an hour, you're just burning off a little over 1 can of that. So think about the things that you're putting in your body in a day as well. And then how much more energy is burned while walking at 3 miles per hour instead of sitting. So if you're sitting and riding, that's 2 calories per minute. And so you can do that math to compare. So we've answered guiding question 3, and now we're looking at 4, the energy equation. So in many ways, your body is similar to a machine. It requires a certain amount of energy to perform its tasks. Some tasks, like building bone and muscle, require a lot of energy. If your body does not receive enough food energy, then it will not be able to perform some of these tasks. In fact, your body will end up using its own muscle tissue as an energy source as a last resort. So on the other hand, if the body receives more food energy than it needs to do its task, the energy will be stored for future use. the body stores extra energy in the form of fat cells. Continuously providing your body with more energy than it needs causes a buildup of fat storage. So to keep your body working at peak performance, it needs the energy that you put in to equal the energy it expends. So this is your guiding question for what equation would you use to determine how much total energy your body uses on a daily basis? So you would take your resting energy requirements that we did earlier, and then you add that to your burn performing activities. And this is the sum, the total amount of calories you need to ingest just to break even. So here is the science notebook activity, and what you need to do here, it says use the data table that shows the estimation of your daily resting energy expenditure and explore how calorie requirements change as a person gets older. So we'll follow the steps and calculate the REE for a person over time. And then we'll record those calculations and notes in your science notebook. So decide to calculate the REE for a male or female. So maybe you want to do this for, if you're a female, for a female, just so you can get an idea of what your REE is for yourself. Then it says choose an adult weight. So you want to pick an average weight. And it says calculate the REE for the adult. And it says we're going to do this a couple different times, from age 18 to 29, 30 to 60, and then over 60. And assume that the adult maintains the same body weight at each age. All right, so they gave you an example here. So you're just modeling exactly what you're doing, like the example. And then you'll answer these questions. So if we take a look at the example, they chose a male that's 154 pounds at age 20. So to do the math there to get started, 154 divided by 2.2 is equal to 70 kilograms. And then they did 15.3 times 70. And that gave, we did the plus 679 because of the age 20. And that gave us our resting energy requirement of 1750. Okay, so then for females, it's a little different. So you can see 121 pound female uses 1,304 calories, the resting calories. And so how does the REE change as a person ages? So as you plug these numbers in, I should see calculations in your notebook activity for these different age groups. So these 3 age groups. And then to get a range of values, you simply add or subtract a normal 10% variation to the RMR estimate. All right, so this is age, your example. So you're calculating your resting energy expenditure. And then this covers, so a male example, 10% of that is 175 calories. So in a normal range for this person per day would be 1,575 to 1,925 calories per day. And then a female, so they're saying 10% of your calories would be used for everything above your resting requirements. So this would be 10% of this person's resting would be 130 calories. So in a normal range of that would be 1,174 to 1,434 calories per day. All right, so you're answering these questions in your science notebook. One, how do these change as a person ages, and what do these results indicate about how the body's metabolism changes over time? So in order to answer these, you need to have your calculations showing as well. So it tells you exactly what to do here. Choose male or female, choose a weight, and then calculate the resting energy expenditure for these age groups. So 3 different calculations. And then if you want to take a look at these numbers down here to get the RMR estimate, you're able to do that math. So you'll have that example as well. All right, and that's to maintain the weight that you listed in your original example. So if you want to lose weight, then you would have to take in less, or if you wanted to gain weight, you would have to take in more. All right, so that's how you do the notebook activity. And hopefully you've gotten the notes and all the guiding questions answered. So with that, you are finished with the lesson. Definitely come see me in Help Lab or at the end of a live session if you need some extra help, and have a wonderful day.